All right, so this is our week 6, assignment 3. So let's wrap up our conversation about assignment 3 today. Assignment, of course, is our desktop calculator. So today I would like to focus on basically the assignment requirements, what you need to do. So you can see that you're going to be starting with already existing project. In fact, if you go to the samples page, right, the assignment handout is asking you to download this version 3. So why 3 different versions? The 3 different versions are there so that you can compare the smallest version of it, which supports only plus and minus, which then gradually grows to support more grammar rules. So version 3 is actually begins to support all of the grammar rules specified in this assignment, which in summary, if we take another look at these, is capable of handling the pluses and minuses, working with numbers. Then it adds multiplication, division, except the remainder. The remainder is not implemented. And then it adds also like unary operators like plus and minus, so that we can start writing expressions such as, for example, we could have written 1 plus minus 2, right? Or we could have written 1 plus minus 2, and it'll understand what this means, right? So in reality, it's the same as 1 minus 2, right? So anyway, but you can use unary minuses with the current version of the project. So without further ado, let's go ahead and actually download it. So let me pick the location, and then I will start NetBeans. I have 2 versions of NetBeans here, so let's just get started with NetBeans, and we will create new project. And once we create new project, we will download the sample code, and the sample code is, of course, this calculator version 3 sample. We'll make sure that it compiles, and this is where you need to get started doing this homework. So let me quickly finish my setup. So I will simply go ahead and create new project, and just a normal starting point, and this will be my location. I think it's the same location as the last one, and the name of this will be week 6 demo, right? Week 6 demo. I obviously will not be creating main class because I will be downloading everything. So let's finish this, and I will close the previous project, and this is my new project, and I'll take a peek at the name I've used with this demo code that I posted online. So it's this specific package name, so I'll just use that package name. Source packages, new package, and set it to calc version 3, so that all I have to do is basically pick the location, which would be week 6 demo today. And so the source and this package name is going to be my location. This is where I'm going to be downloading everything, so that's nothing new, right? And I just go to my sample page and download everything. Download main, download validator. The token stream, that should sound somewhat familiar. The node class, and finally the Lexer class. All right, so I think it's all I need right now. And if I did everything right, I should be able to basically go ahead and build the application and test it. I'll first build it. Okay, so this tells me build successful. Hopefully you can get to the same results, and that would be our starting point today. So if we run this application, of course, it's going to ask us for the main class, and we specify that. So similar to what we try to advertise here with unary operators, let's try something like what we just tried, 1 plus minus 2, for instance, right? So you can see that the program actually makes a distinction of this minus as being the unary operator. So this is not a binary minus, which requires a left-hand side and right-hand side. Rather, this is just an unary minus, which is perfectly fine with arithmetic expressions. We all understand that. For the sake of completeness, there's also unary plus, right? So 1 plus 2 is the same as 1 plus 2, right? So that is still recognized as unary plus, but it's important that that type of recognition exists in the system. We also have multiplication and division now in the system. So if I say 1 divided by 0, which should be basically not a very safe operation, but because I'm actually not doing any computation, all it does right now is basically just collecting the data about the expression and building this subtree of nodes, which of course will have the division operator at the top and the left hand side and the right hand side numbers, which is 0 and 1. Okay, so although it may not be exactly a very safe operation, right now the program says success simply because it was able to understand the grammar, and it's just basically one number divided by another number. So in this same regard, I can say 1 plus 2 minus 3 divided by 5 multiplied by 45 and so forth, right? So all of this is processable, and the program understands how to deal with this. And as you can see, what it currently does, it is just printing the result of interpreting the structure of this arithmetic expression and essentially building a subtree of it. So let's just quickly demonstrate what happens here. So when we say that, for instance, let me do this one more time on the whiteboard. So if we say 1 minus or plus minus 2, what happens is that, of course, we're constructing a set of nodes. First of all, remember that this entire input is tokenized by the program. So we have tokens such as 1, plus, right? And then minus, of course, and the 2 is also another token. But the way these tokens are processed is that, of course, the plus goes to the top of our tree. It has the left-hand side, the right-hand side. On the left-hand side, clearly it has number 1, basically the node that stores number 1. However, over here it stores minus, but this is an unary minus, and unary minus storage is organized like this. The right-hand side actually stores the operand of unary minus, and the left-hand side is left null. It doesn't contain anything. This is the way I store currently the internally. This is the way this is interpreted with unary operators. Basically, the same kind of node, which is class name AST node, is instantiated, and for the unary minus, there's a number stored on the right hand side, but null is stored on the left hand side of this specific type of minus. And this is the way to distinguish between unary and binary operators, right? So for instance, if I wanted to introduce some kind of other new operator, unary operator like this, I'll just use @ sign for, placeholder. So if this is an unary operator, it's going to store information like this. The left-hand side will be null, okay, and the right-hand side will be whatever the operand there is, right? So some kind of number at this point, 123. All right, so this is what I have so far, and we can take a look at the code just to basically refresh our conversation about the actual code a week ago.